Hello class, today we are going to be learning about solving quadratics. Remember our quadratics, are functions where we have a square in them. We'll be learning how to solve quadratics and specifically by factoring. We're going to look at a couple different methods in this unit, but we're going to cover factoring once again, but specifically with quadratics. So today, you want to make sure that you can solve quadratic equations by factoring. Now, we use something called the zero product property when we're solving by factoring. And all this means, our zero product property, is if I have two numbers multiplying together and the product is 0, then one of the numbers we're multiplying has to be 0. So for instance, if I have x times y times z is equal to 0, either x, y, or z has to be 0. Doesn't matter which one. So if I had x times 0 times z, we'd get x times 0 is just 0, and z times 0 is just 0. But in general, if we're multiplying two things together, anything times 0 is 0. The reason that's helpful for us is if we get an expression into factored form, we can set each of those factors equal to 0. So for our first expression here, this is already in factored form. We know it's in factored form because everything is in a parenthesis multiplying by another parenthesis. Now what we can do, since we have a number times a number, each of these parentheses is representing a number. We don't know what it is because we don't know what x is. But if this is equal to 0, I can set both of the factors equal to 0 to find my solutions. So if I had my x plus 8, I'll set that equal to 0. And I'll take my x minus 5 and set that equal to 0. Subtract 8 from both sides. Find that x is equal to negative 8. Then we add 5 to both sides to find that x is equal to 5. So my two solutions here, we have 5 and negative 8. If we think about it, if I were to plug either of these numbers in, say I plugged in negative 8. Well, negative 8 plus 8 is 0. So I'm going to have 0 times something, doesn't matter what it is going to be equal to 0. Okay? I want you guys to take a second to try to set these factors equal to 0 and figure out what our values of x would be. Okay? Setting each of our factors equal to 0, we should have gotten x is negative 9 over 2, or 1. And we should have gotten 11 over 4 and negative 5. Take a second, check your work, see if you made any mistakes. All we're doing is setting each of our factors equal to 0. We did this earlier in the year, working with some different polynomials. We're just going back to practice it again, specifically focusing on quadratics. Okay? Alright. So, as a reminder, roots or zeros of a quadratic equation, those are going to be our solutions when it's set equal to 0. But in general, if they're asking you for roots or zeros, we're setting our equation equal to 0. What that does is it lets us solve for any equation like we just did. If we can factor it, then we can set our factors equal to 0 because we're searching for the roots of the zeros. It's very important that our equation is equal to 0. Otherwise, we can't use that zero product property. Let's look at an example. Notice how my equation is set equal to 0. That's important. It's got to be set equal to 0. Now, if we're going to factor this, I'm going to use, I think some people call it AC method or Berry method. It's a method I prefer to use. We'll take the number in front of the first term and the number in the last term. Multiply them together. So we have 1 times 36 is 36. Now I want factors of 36 that add up to the number in the middle. So they multiply together to give me 36. Add them to get negative 12. Okay. Two numbers that multiply to give me 36. Well, I have 36 times 1. And I need a negative, so they both need to be negative. These add up to negative 37. But I want negative 12, so these are no good. Let's try a different set. Let's try, well, negative 12 times negative 3. That's 36. If I add them together, I get negative 15. So once again, we want 12, so no good. Let's try a different set. If I have negative 6 times negative 6, that gives me a positive 36. And if I add them together, we get negative 12. Which, that's what we were looking for here. So these are going to be our factors. So we take our factors, break up the middle term into two new terms. And now we can factor by grouping. Look for what's in common with your first group, and look what's for common in the second group. With the first group, h squared and negative 6h both have an h in common, so I'm going to factor out h. Divide h from each term. So h squared divided by h is going to give me h. Negative 6h divided by h is going to give me negative 6. Looking at my second group, my 6 and 36, they both have a factor of 6. So I'm going to bring that out. Now, I want the inside of my next parenthesis to be exactly the same as this one. So instead of leaving a negative h there, I'm going to factor out negative 6 so that the inside of this term will be the same. Dividing each of these terms by negative 6, because that's what we factored out. Negative 6 divided by negative 6 cancels out, so we're left with h. 36 divided by negative 6 will give us negative 6. Now I want you to notice something. Both of these terms have a factor of h minus 6, so I can factor that term out. So I factor out, oh, that's not really legible, so we'll just use black. I'll factor out my h minus 6, and left inside of the other bubble, I have my h minus 6 left over. Remember, this whole equation from the beginning was equal to 0. So now we have factored form, and it's equal to 0. So we can use that zero product property. What it does is I take each of my factors and I set them equal to 0. So I have h minus 6 is equal to 0, and h minus 6 is equal to 0. Add 6 to both sides. We find that h is equal to 6, and also that h is equal to 6. So we have one solution, which is 6. Okay. All we're doing here, factor. If you prefer the box method, use the box method here. I prefer to use some people call it Berry method, but I call it factoring by grouping. I prefer to factor by grouping. But if you do prefer box method, use box method. Okay? Let's try another one. We're going to solve this equation by factoring. Notice something here. Our equation is not set equal to 0. Our last one was. This is what's new for today. If our equation's not set equal to 0, we have a problem. We need our equation to be set equal to 0. So what we can do is manipulate the equation. We can manipulate the equation so our equation is equal to 0. What we're going to do is move everything to the other side. We're going to move everything over. So in this case, if I have 9 on this side, I want to get rid of that 9, so I'm going to subtract it. Opposite of plus 9 is minus 9. I need to subtract it from both sides because we have an equation. So we're left with x squared minus 10x minus 24 is equal to 9 minus 9 is 0. Okay? Now, I want you guys to take a second, factor this, and set each of your factors equal to 0 to solve for x. Okay? So we should have found that x is equal to -2 and that x is equal to 12. If we wanted to check our answers, we could plug these back into the original equation. But pretty much, if we have an equation that's not set equal to 0, we can move everything over to make it equal to 0 so we can factor it and then solve. If we skip this step of moving the 9 over, we can't use our zero product property at the end. Alright, let's look at another example. I want you guys to solve this. Take a couple seconds. Remember, set your equation equal to 0 by moving the 30 over, and then factor and set your factors equal to 0. Okay, hopefully you had a couple seconds to give this a go. Once again, move the 30 over so that our equation is set equal to 0. And we need to factor, so take the first number times the last number. 12 times -56 gives us -672. We need to find a set of factors. When we multiply them, we get -672, and when we add them, we get 11. That's going to be 32 and -21. Split up the term on the inside, and then factor by grouping. 12g squared and 32g both have a 4g as their greatest common factor, so we factor it out. -21g and -56 have our greatest common factor of -7, so we factor it out. Both of our terms have a 3g plus 8, so that comes out, and we're left with 4g minus 7. Take each of our factors, set them equal to 0 using that zero product property to find that g is equal to -8 over 3 and 7 over 4. Okay. Take another second, give this one a go. Move the -64 over and factor. Alright, we had a chance to look at this. If you wanted to, you could have used box method. You also could have used the berry method. Personally, once I moved over the 64, I noticed that we had a perfect square and a perfect square. So I used our difference of squares. So square root of 49 is 7. Square root of x squared is x. Square root of 100 is 10. So I have 7x minus 10 times 7x plus 10. It's a little bit of a review of our difference of squares. You'll get to the same place if you use the other methods, but when you can recognize difference of squares, it can be a lot quicker. So our answers should have come out to 10 over 7 and -10 over 7 once we set our factors equal to 0. Alright. Now, if we have more on this side, that's okay. We're going to do the same thing. we're still going to move everything over. That is a C, by the way. We're going to move everything over, just like we have been doing. Make sure the right side of the equation is equal to 0. So I'm going to subtract 90, and I'm going to add 18h. Here, we'll even do them in separate steps. You can do them together if you like, but we'll do them separately just to show what's going on. Subtract 90 from both sides, so I'm going to get 40h squared minus 18h minus 90 is equal to negative 18h. Okay, getting closer. Move my positive 18h over. These cancel. These cancel. I'm left with 40h squared minus 90 is equal to 0. Now before I try to factor this out, you noticed we have a greatest common factor here, which we can use to make the problem easier for ourselves. 10 goes into 40 and 90. So I'm going to factor out 10. So I have 4h squared minus 9. Okay? I can divide both sides of my function by 10 to get rid of that. So now we just have h squared minus 9 is equal to 0, or 4h squared. The reason we can do this is because 0 divided by any number is still 0. Okay? Now, if you notice, we have another difference of squares. So I'll take the square root of the first term. Square root of 4 is 2. Square root of h squared is h. Square root of 9 is 3, so I have minus 3. Same thing again, except now we have a plus. Set each of my factors equal to 0. So we'll do it up here. So I have 2h minus 3 is equal to 0, and 2h plus 3 is equal to 0. Add 3 to both sides. We'll get 2h is equal to 3. Divide both sides by 2 to get the h is equal to 3 over 2. Similarly, subtract 3 from both sides to get 2h is equal to negative 3. Divide both sides by 2 to get h is equal to negative 3 over 2. Those will be our two solutions. Alright. Last one. Take a second, solve for x, move everything on the right side to the left, and then set your factors equal to 0. Okay, so we should have gotten negative 4/3 and 5. Just hooking back to what we started with, we should know how to solve quadratic equations by factoring. We move everything from one side over to the other side, so our equation is equal to 0. And then we can factor and use that zero product property to solve for our zeros. Have a great rest of your day.